So dear friends, very good morning. In trigonometry part first, we have read where trigonometry lies in the spectrum of whole mathematics. It's a part of geometry. In geometry, as I have told in the you can see that in the last part of that one video, I have end that video at this point. This is geometry, and I have told trigonometry. Trigonometry is a part of geometry. Coordinate geometry. Coordinate geometry. This was in class 10th, chapter number 6. This is coordinate geometry, chapter number 7, and trigonometry, chapter number 8 and 9. So these are related. The main actual portion is geometry, and class arithmetic 5 number chapter arithmetic progression was there. So arithmetic 5 number chapter arithmetic, what I have told in the last class. So in geometry chapter number 6, in chapter number 6, page number 133, what is written? Theorem 6.4. Theorem 6.4. What does it say? If in two triangles, sides of one triangle are proportional to the sides of other triangles, then their corresponding angles are equal, and hence the two triangles are similar. Page number 131, Theorem 6.3. These are mutually related. In 6.3, if in two triangles, and the figure is made like this, one we have a small little triangle, that is A, B and C, and another one, just it is of same type but somewhat of big size. Same type of big size. Type means angles, and this is D, this is point D, this is E, and this is F. So in 6.3, 6.4, both you may have. In 6.3, if in two triangles corresponding angles are equal, then corresponding sides in the same ratio. Corresponding angles equal. A, B, C, just like this was A, B, C, similar, this was the sign of the similar, A, B, C similar to D, E, F, means A corresponding to D, means angle A equal to angle D, angle B equal to angle E. This is, I have made 2 times, this is equal to this, and this is angle C is equal to angle F, means this, I have made it 3 times. So this is angle to this. So all the 3 angles are equal. and further it is written, no, at a time only two angles should be equal. Means if two angles are equal, then obviously the third angle will be equal. If the angles are equal, not about the size, angles are equal, means the two triangles are of the same type, same quality. It may be small, it may be big size, it may be of its double, its triple. Triple means all the sides will be in triple, and the area will be 9 times. So that's another theorem. Means if this is double, so this AC will be also double, this here. So it is written, if all the angles are equal, then similar, all the angles are only two angles, then what is written, AB. In here, how many types of ratio you can form? This is AB, this is BC, and this is AC, means 3. So it was written here AB, after that BC, and after that AC. These are in same ratio, means divided by is equal to AB. AB corresponding, what is the corresponding of AB? First and second. You may say A and B, first, second. So this is first and second, DE. BC, second and third. So you may take second and third, EF. Corresponding, you have to point corresponding. By the way, it is side, so you can take FE also, ED, but it is much better to take this one, this second and third, first, second and third, just like I have made this one. AC, first and third, so this is first and third, D and F. Corresponding means angle A will be equal to angle D. So that's why where A is given, I have written D. Where B is written, I have written E. You may say B corresponding to E, A corresponding here, A corresponding to D. So actually angles A is like this, angle A equal to angle D. So A and D, B and E, second and second, first and first, third and third. So these are corresponding angles are equal, then corresponding sides are in the same ratio. Angle A equals to angle D, angle E equals to angle E equals to angle B. Yes, because angles are equal, and like that angle C is equal to angle F. So this was chapter number 6. This is the foundation of trigonometry. In trigonometry, what we do, we will make tables, we will make practical, and we will get this ratio. The difference is only here we have taken any types of triangle. This is acute angle, you may take right angle also, you may take obtuse angle also. But in the trigonometry, first we will define this ratio. This ratio. How many ratio? 1, 2 and 3. And you can convert also. Means DE upon AB, EF upon BC, DF upon AC. So we have 3 first, this divided by this, or you may change this also. So 3 ratio and inverse of these 3 and 3, 6. So here you will in trigonometry you will see this is the sine, some will be sine, then cos, and then tan. 3 ratio will be there, and after that the inverse of this sine to the inverse cosec, cos inverse sec, and tan inverse cot. In trigonometry, I will tell. Actually, geometry is holds for the all triangles. In trigonometry, what we will define sine and cosec, this one for the right angle triangle. For the right angle triangle. So these are the same ratio which will be used in trigonometry. but for the right angle triangle. So the question in coordinate geometry, in chapter number 7, also this ratio was used. Where? This is sine, cosec, and this. In chapter number 7, this ratio is used. Where? In chapter number 7, section formula. For the chapter number 7, you may see chapter this. Let me write here. Chapter number 7, page number 163, and lines number 1, 2, 3, 4, 1, 2, 3, and 4. Fourth number lines. Fourth lines, it is written, it is used in section formula. Section formula. This is called proportionality theorem. And in the trigonometry, these all are related. This you may say chapter number 7, page number 163. This ratio, line fourth number line, fourth line, and section formula. Section formula, it is based on this one. So I am here to introduce trigonometry. So the actual question is, I have told you sine, cosec, these will be divided, this defined only on the base of right angle triangle. Why it is so? I will explain you. So first let me raise. Till then you may open. So what I have told you, chapter number 6 and chapter number 7, it remains to teach chapter number 8. Chapter number 8, I have told sine, cosec, trigonometrical ratio. The same concept will be used, trigonometrical ratio. And what I have told, trigonometrical ratios are defined. Here the triangles was normal, any triangles you may take in trigonometry also. But now come on the page for the chapter number 8. Chapter number 8 and page number 174. Chapter number 8. So chapter number 6, what I have written in chapter number 6, similarity. In chapter number 6, it was 131. In chapter number 6, it was page 131 and 132. Theorem 6.3, theorem 6.4. Actually 6.1 and 2 also, both are same. 6.1 and 6.2, because with the help of 6.2, 1 and 2, 6.3 is proved. 6.1 and 2, 6.1 and 6.2, these are mutually inverse to each one, and these are also 3 and 4. 6.1 with the help of 6.1, this is the foundation. With the help of this, it is proved. 6.3. Okay. And in coordinate geometry, what I have told, page number, coordinate geometry, section formula, na? Yes, section formula, page number 163. Page 163, fourth line This is section formula. The both are same thing. Means this is the fundamental. With the help of this it is derived, and with the help of this trigonometrical ratio which we also derived. So in chapter number 8, come on page number 174. Page number 174. Their terms is trigonometric, not trigonometric ratio. In short form it is called TR. In page number 174, 175 obviously. The whole concept is about right angle triangle. 174, 175. And most of the questions will be for the right angle triangle. But let me tell you, trigonometrical, what sin theta, cos theta, will not only for the right angle triangle. All types of triangles it is defined. It will be in class 11th. In the class 10th, for chapter number 8 and 9, all the questions, most of the questions, not all the questions, most of the questions will be of right angle triangle. Some questions in chapter number 9 are obtuse and acute also. So let me ask a question. Why the trigonometrical ratios are defined only for the right angle triangle? Because it is figure here in this one, right angle triangle. In right angle triangle, two lines, two sides are mutually perpendicular to each other, 90 degree. And this is most of the case when we make any building. This is the ground, so this will be the building. This will be the tree. This will be the any temple, any minar, any chimney. This will be the ground, and this is. So in the chapter number 9 you will find it. Chapter number 9, suppose this is the ground, and any chimney. Some questions it is in chimney, it is in building. In chapter number 9 you will see. And most of the things will be of 90 degree. It may be the shapes is different, but when we will find height, so height means perpendicular. It may some questions aeroplane is flying above the ground. So what is the height? So for the height you will draw perpendicular bisector on the ground, perpendicular bisector for the height. Otherwise many height may be there. Out of these, suppose this is an aeroplane, it is flying above the ground. So what is the height? So no, this will be not height, because this is not right angle. The right angle is the height. Aeroplane is different from the building. Building is just above the ground. Some people may say, sir, Pisa minaret is inclined, is not perpendicular, Pisa. So the trigonometry will be applied. So I will tell yes. So let me tell, it will be also applied. The same thing which I am telling you. Trigonometrical ratios are defined especially for the right angle triangle. Why? The question is why it is so. So I have told some examples, practical examples that will be used in chapter number 9. Many things, most of the times you will see in chapter number 9. So let me come on chapter number 8. For the right angle triangle. So the question is very good. Can you guess? Yes, it is definition. So why we take right angle triangle? Theorem 6.3, 6.4 will be used in different format for the trigonometrical ratio. Why it is so? Just like, let me have one times written, one times what is the trigonometrical ratio? Just like we have, for the examples I am telling you, this is right angle triangle, where this is 1 and this is 1, means this was a square of one side, 1 1 1, and we cut the squares in two parts, squares of two parts, so 1 1 will be there, and in the this is 1 1, so Pythagoras theorem you can use, this will be under root 2, and this will be obviously 45 degree, so this will be also 45 degree. At a time, if this is right angle triangle, so only one angle is enough to tell what is the value of the second one. So this is 45, so obviously this will be 45. Equal angles, so opposite sides are equal. Many in the class 9th, many things we have read. In a triangle, the sides opposite to the greater angle become the greatest. This is 45, this is 45, so sides are equal, angles are equal, so opposite sides will be equal, 45, so angles sides are equal. This is 90 degree, the biggest angle in this triangle, so the sides will be biggest, under root 2. Under root 2 is actually 1.4, 4123, like this, dash dash dash, will not be, it's an irrational number, root 2. And that was found by the Pythagoras at that time. He had an intention to write under root 2. Under root 2 is equal to something upon something. He want to write just like 1.4, you can write 14 upon 10. Suppose I take some approximation only, 1.4. So 14 upon 10, and after that you can write 2 7 upon 5. This is 7 upon 5. So he tried to write under root 2 in the terms of something upon something, and he was unable to write. When he divided 5 by 7, it was terminated, but this is not terminating. Okay. So that was the story of root 2. Okay. So what about, I was telling to you, so this is the very fundamental. Let me raise it. This is very fundamental. If you have a triangle similar to it, similar means all the angles will be equal, but of the different size. Suppose I take 2 2 2. Suppose I had, this is 1 and this is 1. Earlier this was under root 2. I get double of it, means I may take 2. This is the 2, and this is also 2. This is 2, this is 2, means, and this is right angle triangle. This is 2, this is 2, right angle triangle. Three things you have known. 2 means side, angle and side. So be confirmed, you have known all the things, because the sides are opposite are equal, so angle will be equal. This is 90 degrees, so angle will be x plus x, means you can calculate, this is 45 and this is also 45. Okay, side, angle, side. So this is 2, 90 degree. So what will be the value of this one? This one, with the help of Pythagoras theorem, you can find this will be 2 root 2. So what can we say? What can we say about the ratio side, angle, side? This is 2 root 2, and obviously this was 1, this was 1, and this was under root 2. So in the class, in the chapter number 6, it was told this ratio will be equal to this. This was 1 and this is 2. So this is ratio 1 and this will be 2. And this is also double, 2 times of this, 2 times of root 2. Means these are, this root 2, let me raise. This is 1 and 1, this is not 1, means in the class, in the theorem 6.1, the theorem was like this. 1 1 and under root 2. These are parallel, this will be parallel also. If these are parallel, so angles will be equal 45 45. This was in section in theorem 6.1 and 6.2. Okay, and suppose I had one means I will keep the same type of the triangle. This is one, this is one, so obviously this is 45 degree, this is 90 degree. If we get it three times, 1 2 and this is 3, means this I have get it 3 times, and this again 3 times, 1 2 and this is 3. This was one, this was one, this was a small Pythagoras small right angle triangle. And if we increase the ratio, this is 1 and this, if we have 3, this is 1 and if we have 3 ratio, so when we will join, you know what you will get here. This was 1 1, this was under root 2 na, so 3 times of under root 2, 3 root 2, and this will be parallel to this, so that angles are equal, 45 and 45. So I have told you this is the double of the sides, this is the double and this is the triple of the sides. So you may say, sir, any type, any multiples. So that's why we may have a formula in algebra will enter here. If this is A and this is A, this is 90 degree, this is 45 degree, A 90 degree and this is 45. So always you can have, and Pythagoras theorems, you will get A and root 2, A root 2. So this is the actual formula. When A is equal to 1, so this will be 1 1 and 1 root 2. When A is equal to 2, this is 2 2 and this will be 2 root 2. This is the 3, this is the 3, this is the 3, so that will be 3 root 2. So here we are getting the ratio. Ratio means what we can say, sir, in this type of any figure, if right angle, you have any right angle, if you have any right angle 90 degree and one angle is 45 degree, then if you have what I have told you, the two types in any right angle triangle, if you have one 45 degree, means two angles I have told you, right angle means 90 degree, this is 45, then what can we say, sir, two sides remains same, of same length, means ratio of this to this is equal to 1 to 1. This will be same means ratio 1 to 1. And the third one, hypotenuse will be of root 2 times of this, root 2 times means some डेढ़ गुना, डेढ़ multiply 1.4, actually 1.4 it is 1.5, nearby डेढ़ गुना. If this is 10, this is 10, so that will be 10 root 2. Means you have found a blueprint for this type of right angle triangle. So what we have got, sir, any right angle triangle, if one angle is 45 degree, then the hypotenuse will be root 2 times of any sides and the other two sides will be equal. These three informations, na? So that will be used in the trigonometrical ratio. Ratio means this will be equal to this 1:1 and this will be 1:2, or you may say root 2:1. So very soon this is 1, this is 1. So we don't write, and you will find A ratio A. This is A ratio A. So that will be 1:1. So we will use this triangle for the definition. A ratio A upon 2, A upon A root 2. So that will be 1 upon root 2. This is A will be cancelled out. You may take also this one. So we can have 3 times of ratio and 3 times of ratio. These all are similar triangle, chapter number 6. So let me write all these in the format of chapter number 6. Suppose I write this one. Okay. In chapter number 6, it was written like this. This is suppose A, B and C, and this is D, E and F. In chapter number 6, what was written? Angle A is equal to angle D, means ABC similar to DEF. DE and F. DEF. After that, AB, then BC, then AC या CA, AB, BC, CA ratio equals to AB, corresponding AB, this is DE. DE equals to BC, BCEF equals to CAFD. So what you can write? AB upon DE. AB upon DE means this is 1 upon, this is 1, this is 3. 1 upon 3 is equal to BC. This is also 1 upon EF. This is also 3. And what about this CA? This is under root 2 and this is 3 under root 2. So under root 2 will be cancelled. 1 upon 3. You will get 1 upon 3. Means we may say this triangle is 3 times of this triangle is 3 times of this triangle. Or you may say this is 1/3 of this. We have two methods to say it. This triangle is 3 times of this. Okay, this triangle is. So in the ratio, you may say also DE upon AB means 3 ratio and 3 inverse ratio. Okay, so come on. So this was, have you understood? This is 3 times of, all the sides are of 3 times. This is root 2, so this is 3 times, 3 root 2. Okay, so that was in chapter number 6 and that is in trigonometry. And earlier we will see the ratio we will define in perpendicular hypotenuse. What will say, I will tell you. So you have seen these two triangles are related to each other, means similar triangles. So trigonometrical ratios talk about similar triangles. This is. So in trigonometry, this same ratio, 3. So it is called, in just come on the page number 174. Page number 174, trigonometric ratio. So what is that? Hypotenuse is fixed. Something is definition. Some definitions are there. In right angle triangle, this is 45 degree. This is 90 degree. 90 degree. Hypotenuse is fixed just opposite to the 90 degree. This is fixed. Hypotenuse. It is 1. If you take this angle 45 degree, so 45 degree is made with the two sides, this hypotenuse and this. So 45, you can erase this, means only the length is fixed, triangle is made. This. So this angle is made with between two sides, what? Hypotenuse and this. So for this angle it will be base because it is already named base, and for this angle this is just opposite sides. And what is nature? Its nature is 90 degree opposite side, so it will be perpendicular P for this angle. Or you may say normal also. So now we have started the definition: base, hypotenuse and perpendicular, normal. For this angle, this is the base, and don't be confused, because I have told you in this triangle, this is hypotenuse, it is fixed hypotenuse h. Let me write in short, h. This is 90 degree. If you take this angle, so this was this, between this and this is the base. If you take this angle, this is hypotenuse, so this angle is made between these two sides. What? One is the hypotenuse and another one is this side, this one. So for this angle, that will be base for just like A, B, C, A, B and C. So that is A, B and C. For this angle, if you change the angle, that is why in the book it is written, hypotenuse is written, page number 174, 175. We write base and perpendicular, but in your book it is written base means side adjacent to angle. This is base means adjacent. Adjacent means joint with the angle. Base, whatever we have written base, in your book it is written adjacent to the angle. Base means adjacent to the angle. And what is perpendicular? I have written normal, it is written opposite to the angle. This is opposite to the angle. Opposite, and this is adjacent. But look it, if this is angle, so this is made hypotenuse and this sides, so that side will be base or adjacent for this angle. If you take this angle, so hypotenuse is fixed, this will be base or hypotenuse or base or adjacent for this angle, and this will be perpendicular or opposite to normal, opposite to this one. So the same sides, this is BC may be base for the angle C, adjacent for the angle C, but the BC may be perpendicular normal also for the angle A. So means any angles is formed just like this is our compass. This is any angle, this. So this I have already told, this is the hypotenuse, this one hypotenuse, so that will be base. And if we will take this hypotenuse, this one, so this is hypotenuse, so this will be the base where this angle has been formed, this one. So this will be the base, because for the angle two sides are required. So this is hypotenuse fixed, so this will be the base, and for it this will be the base. So this was the base, and base adjacent, it is given in your book, page number 175. So read one time, look it in your book. And the three TRs, page number 175, TR ratio, TR is given. Sine of angle A, cos of angle A, tan of. So I will teach you. Page number 175. But only one questions I remains to be cleared. Why these definitions are based on, and one thing more, in right angle triangle this and this also is used. You know, this may be this sides and this side, so this is 90 degree. So because in right angle triangle it's fixed 90 degree will be there, so that's why we don't take about 90 degree. So for this 90 degree, sir, which will be base and which will be perpendicular, this and this, just like I have told you now, this, the two triangles, this and this one. So for this, suppose these two sides are this one and this, so which one you will take base and perpendicular? Most of the times you will see sine 90 degree, cos 90 degree is very less defined, and obviously most of the times we will take this angle or this angle, not of this angle. In this figure you can take any, because hypotenuse is fixed. So for this is also base, perpendicular on base, because these two are perpendicular to each other, perpendicular. So if you take perpendicular, so this is base, if you take base, this is perpendicular. So like that for this angle, because angles is made with the between these two sides. Okay, the final questions remains to be, and why the 6 ratio, page number 175, why the 6 ratio? The ultimate ratio we have 3, sine, cos, and ultimate is 2. With the help of these two we get 10, third one, sine, cos and tan. And the inverse of this, sine inverse cosec. Cos means we have only two fundamental. In these two ratio all the three sides will be covered, sine and cos. You will see tan is just another one. For these three we two ratios are enough, sine and cos. Tan is derived from this sine and cos, and the inverse obviously sine, cosec, cosec, so tan and cot. So the fundamentals are sine and cos, any two. How it is related I will teach you in the next part. And what I have told you, ratio, how the ratio, TR ratio are related to the geometry chapter number 6, and why it is 3 and 6. You may not have 7 ratio or 5 ratio. Why it is 6? Because it is 3. Why it is 3? Because actually it is 2. Means more than 6 is not possible, and more than less than 6 means 5, 4 will be somewhat less. But most of the times you will see the use of sine and cos, and this will be used but in not so much amount, so much quantity. Sine, cos and tan will be used, sine, cos, and these are the fundamental. In chapter number 9 mostly tan will be used in chapter number 9, because it is related to the height. So why it is, what is this, why it is related, in the next video.